Alright guys, we are going to try to go through this while my kids are eating lunch and watching TV. We will see what happens. Okay, for completing the square, we want to make sure that we only have two terms on each side. So I'm going to move that minus 13 over to the other side by adding 13, but I'm going to keep a space here because what we want to do is we want to turn this right here into a perfect square trinomial. So for this to be a perfect square, we got to figure out what number would this have to be so that we could write it as a perfect square. So for this to be a perfect square, you're going to use your middle term, and you can do a little sidebar here. You're going to take half of your middle term, which turns out to be 6, and then we're going to square it to get your new C term. So that should be, this missing term here should be 36, so that I get a perfect square trinomial here, which then I could write as x plus 6 quantity squared. But if you add 36 to each side, or to this left side here, we have to make sure that we add 36 to this side also. So we're going to get x plus 6 quantity squared equals 49. Okay. Then, since this is a perfect square and we're trying to figure out what x is inside these parentheses here. So we can't get to what's inside the parentheses unless we get rid of them. So we need to undo this squaring here by square rooting. But if you square root the left side, you got to make sure that you square root the right side. So we're going to end up with x plus 6 is equal to 7. But there's also x plus 6 could be equal to negative 7 because the square root of 49 is also negative 7. So then we're going to solve each of these equations for the missing variable. And we get x is equal to 1 and x is equal to negative 13. So for this original problem up here, sorry, I totally cut off the problem there. For this original problem up here, it would have been easier to just backwards FOIL that and say, okay, what multiplies to get negative 13 and adds up to 12? And it would have been x minus 1 and x plus 13. And then I would have set each factor equal to 0 and solved it. So in this case, it would have been a lot faster and less complicated to factor it to get the same answer. We'll do another one in a little bit.